Learners, I welcome you. This is Teacher Phillip, the physics teacher of Royal College Namugongo. I welcome you to this platform, and I'm here to teach my senior ones physics. Our topic today is measurement. Understand we would have finished that topic some time back, but there's been some interferences. I therefore preferred to add on from where we ended the other time. Measurements is among other topics that we start with in senior one, in mechanics. And here, when we are measuring, we look at what we call physical quantities in physics and understand the different physical quantities that we talked about the other time, the basic and the derived quantities. So today, I come up with one of the derived quantities. Understand for the other physical basic quantities we talked about them. I'm here to talk about one of them, and this is called density. Density is our physical quantity today that I want us to share about. So density, we must know that some quantities come from other quantities. They come after combining the rest. They don't exist on their own. And if I'm to tell you density is among them, it is a derived quantity coming from two quantities. I therefore take this chance to tell you about density. So class, let me define for you what density is. Density is the mass that is contained in 1 cubic meter of a substance. Rather, it is the mass per unit volume of something. You get 1 cubic meter of something, you get 1 unit volume of something, and then you take its mass, and that mass that you get of that 1 cubic meter of that something is what we call density. Therefore, in simple terms, in real sense, density is the mass contained in 1 cubic meter of a substance. Or I can simply define it as the mass as density is the mass per unit volume of a substance. So class, that's what we call density. What is the mass in a unit volume of something? Understand class, different materials have different densities. For example, if I go to uniform containers of the same space, containers of the same volume, I get like 5 of them, but in every container I put a different substance. Maybe in this one I put sugar, I fill. This one I put water, I fill. In this one I put sand, I fill. In this one I put cotton wool, I fill. Maybe in this one I put feathers, I fill. Understand, by that time the volumes are the same. But if I try to take those containers to a weighing scale and take their masses, I'll find out that they are having different masses. And therefore, that means their densities are different. Rather, their masses that they occupy are different for the same volume occupied. Therefore, this is a statement, but I would like to extend this statement mathematically, whereby we say density is, when we say per, that means we are dividing mass by the volume. Therefore, density is mass divided by volume of something. That is the mathematical definition. Rather, when I express this mathematically, I come up to this. Class, we always, in measurements, every quantity measured, every physical quantity has units. The units in which you measure that quantity. And here we come to density, and I hope if we had come up with units for this, we have to consider the units for mass. We also have to consider the units for volume. Then we combine. Remember, this density is coming from two quantities, and therefore, even the units are out of the two. So, we have, among other units, we have what we call SI units, and then those that are not SI units. So I will start with mentioning the SI